Hello and welcome to our live Q&A with Professor Brian Cox as part of Speakers for Schools. Today we're here at Chawton High School in Manchester, joined by Wally Range, also in Manchester, and colleague Marion Dweevor on Google Hangouts, and all of you who are watching on Google Hangouts and the Guardian Teacher Network. Now today Professor Cox will be taking questions here from the student audience on the future of discovery, giving his thoughts on everything from space travel to what inspires him when he looks at what's happening in science today. Should we take another question from Tom in Year 11?
What do you think would be the most important scientific breakthrough we could make in the near future?
But the more data we get, and the more we look at things like the oldest light in the universe, which is something called the cosmic microwave background, the afterglow of the Big Bang, if you like, that we see in the sky. We've been taking photographs and measurements of that, and they all seem to confirm this idea, this theory, that before the universe was hot and dense, before this Big Bang, the thing that we call the Big Bang, there was some other time when it was doing something else. So there are big questions about how long was it doing that other thing for?
We've got an ethical question now. It's a good one from Mia in Year 10.
Due to there being limited funds in today's society, people may question whether it's morally right to spend so much in space exploration. So how would you justify it?
It's a good question. The answer for me is quite simple. It's that the money that we spend on space exploration is an investment, and it always has been an investment. So let me give you one number. The most expensive bit of space exploration we've ever done was Apollo. It was about 4%, I think, of government spending in the US in the peak years. So it's not an enormous number. It's 4% of the money the government spent, but it's still quite a large amount. Every study that's been done has suggested that the return on that spend was enormous. Numbers like 14 to 1.
Okay, I think we're going to move on to Wales now so that the guys at colleague Marion Dweevor can ask a question. Are you ready down there?
Yes, we are. Good morning.
Hello.
Our first question is going to be from Alan. Go ahead, Alan.
Hi, Brian.
Hiya.
My question to you is, what do you think is the most unsung scientific discovery of recent years? What do you think has gone under the radar?
That's a great question. The most unsung scientific discovery. It's something. This idea that we might have a theory that addresses what happened before the Big Bang. That, to me, is something that it changes. It's culturally significant, that theory, and I think it's because it's quite new and quite difficult. It hasn't quite seeped into our understanding. So the idea that understanding photosynthesis, which is a prerequisite for complex life on Earth, might require quantum mechanics absolutely fundamentally to explain the processes, I think is really interesting.
If you could go back in time, who would you invite to have a meal and a chat, and why?
I'd love to. This might be kind of a predictable answer, but I'd love to talk to Einstein. And the reason is that I think, because my field's physics, and Einstein, I think, was a almost uniquely brilliant mind, certainly one of the greats, undoubtedly. So you could argue that Newton and Galileo, that obviously should be in there. Richard Feynman, more recently, should be in there. But Einstein was absolutely simple in the way that he thought about things. So the very famous example is his theory of gravity is a masterpiece. It's still our best theory of gravity. It's 100 years old next year, and it's still the most accurate theory of gravity that we have. It passes every test that you can throw at it.
Do the TV companies ever stop you going into the mathematics and more complex physics of what you're talking about?
No. The reason is that, well, I wouldn't want to. That's not what I want to do on BBC Two at 9 o'clock. What I want to do on BBC Two at 9 o'clock is to have as many people watch a science program and be introduced to the current big ideas about the origin of the universe, let's say. So you make programs with a particular audience in mind, and so it would be different if you made them on BBC One. You'd have a different audience in mind. Or if you do them on BBC Four, you'd have a different audience in mind. So it's not a question of I think that I would rather just give a lecture and these evil people at the BBC say, I don't think, we don't want you to do that. It's a collaborative effort where you sit there and think, what can we do that will get a big audience on that channel in that time slot?
Thank you for those great questions. We're going to move now to Wally Range High School. Are you ready for your first question there?
What was the question? Sorry.
What advice would you give to a student planning to take up a science
Oh,
career?
right. I would say absolutely. It's 100%. My experience is that it's the most exciting thing. I wouldn't say the most exciting thing. It's an incredibly exciting thing to do, because there's a practical answer, which I actually don't care for too much. The practical answer is that there's a huge shortage of scientists and engineers in our economy. So if you want to be sensible about it, then it's the route to a great career and a great job. So that's a practical answer. The reason I don't care for that too much is I don't think that's the reason you should do it. It's a fortunate side effect that you'll have the pick of 100 great careers. There's a number, by the way, that we need 1 million more engineers in the economy by 2020. So that's about your age range, actually. So we're missing in Britain. We have a need for 1 million engineers at all levels, from apprenticeships all the way through to PhDs, in order to fill this gap in our economy that's opening up because we're a high-tech economy. But actually, what I would say is that to have a job, to be able to go to university for 3 or 4 years, and then if you want to, go and do research, and your job is to explore and understand nature, I think for me that's the most tremendous way to spend, 4 years, 5 years, 6 years, 10 years, or your professional career if you choose to do it.
I think we've got time for one more quick question from Wally Range.
What do you think schools like ours can do to increase the number of female students applying for STEM subjects, such as physics, at degree level?
Yes. It's a very good question. There is a shortage of women in physics. The numbers depends on which university you look at. I think it's of order 15% of physics students are women. It might be wrong there, but it's something like that. It's certainly not half. And it's almost, I could almost ask the question back to you, because it sounds like you're interested in doing physics. But there are many reasons you would want the mix to be 50-50, not only the fact that it should be, but actually, if you think about it, as I said before, we are short of physicists in Britain and actually across the world. And that means that you want the most talented people, the people who are best at physics, to be in physics. So it seems to be there's something that is suggesting to more girls than boys that physics might be, space exploration, exploring planets, looking for life. Those things might not be for them for some reason, which is and it's inexplicable to me when it's put in those terms.
Now we've got schools all around the UK who've been tuning in, watching, and we've had some questions through on social media. First one is from Stephen's Studio School STEM Club. They've actually asked lots of questions, but I'll just choose one. Do you think we should be doing more to solve the energy problems we face, and will there be a more efficient fuel in the next 50 years?
So the answer is yes, we should be doing a lot more. And the answer is yes, there are more efficient fuels. So not restricted to, but I'll mention one which I'm very interested in, which is nuclear fusion. Fusion is the way that stars work, so it works. There are now several fusion experiments around the world which have shown that we can do it in the lab. So we can make little stars, if you like. It's been done several times in different places around the world. So what we have is an engineering challenge and a science challenge to commercialize that technology.
There's quite a big question that's coming on social media from Akil in Dirty, who asks, how much of an understanding do we have of what space itself is, and how can that understanding allow us to grasp the influence of large bodies in space? Do you think that all the planets are like boats, offering displacement in the bucket of water we know of as space?
Right, so the answer to the last bit is no, they're not. Okay. So space is in physics terms, what we refer to it as the vacuum. So then vacuum in kind of a colloquial sense is an absence of everything, right? It's kind of, you think of empty space, and that's what you call the vacuum. But a vacuum in physics is a complex thing. The first thing to say is it's not empty. We now know it's full of something called the Higgs field. So that was the great discovery of the Higgs particle. What does that mean? What it actually means is that the empty space isn't empty. In a technical sense, the lowest, what's the lowest energy configuration of empty space? So physics is often about saying what's the lowest energy this system can get into. So if I hold a ball and drop it, one way of explaining what happens is that the ball is a lower energy configuration. It can give up energy, the potential energy it's got. It can give it up by dropping to the ground. So that's why it goes to the ground, because that's a lower energy configuration than it floating up here.
Unfortunately, that is all we've got time for, so thank you very much for watching today and for submitting your questions. Apologies if we didn't get to yours, and big thanks to Professor Cox for his time. Thanks also to Speakers for Schools, their partners Google UK and the Guardian Teacher Network for helping you to join us today. Thank you.